Hello, I'm Fabio Crameri. I'm a PhD student in the group of Paul Teckley here at ETH in Zurich. We have a look at global mantle convection, and we have a special focus on the linkage between the interior movement of the Earth and the surface topography. And we try to investigate this problem by using numerical models. So far, plate tectonics is an important process at the surface, and there are almost rigid plates which are divided into several pieces, and they move at the surface, and as they move there are new crust is created at certain regions, and at the same time the plates are recycled into the deep mantle again. And these regions, as far as we know it now in present-day Earth, are like one-sided, so only one plate is dragged down into the mantle and the other is staying at the surface. But so far our numerical models always show this double-sided subduction where both plates, both converging plates, are dragged down into the mantle at the same time. So this is apparently not correct, and now we try to do it better by implementing an air layer on top of the model, which allows for topography, which wasn't implemented in the old models. And so the plates can move also vertically, not only horizontally, and build up topography. As a direct implication, our plates are now subducting single-sided, so only one plate is sinking down into the mantle. And that's what our models are about. So we did run this on the CSCS supercomputer, and what they show here is the temperature field and the viscosity field. And here you see the red strong plates which are subducting single-sided into the mantle. So there are several different subduction zones where the plates are sinking down into the deep mantle. And then, in reverse, hot material is moved upwards to compensate for this mass flux. These new models now show that there is an important influence on the whole dynamics of the interior of the Earth if we have only one-sided subduction and not double-sided as before. And this has important implications in our understanding of Earth, as they change the dynamics quite a lot. So this means that mantle material, for example, is moving differently, and which in turn then shapes the downgoing slabs, and we can see it on the surface. And the comparison to nature reveals that the model is in very good agreement with what we see nowadays. And also, I guess these models will have an important influence on future developments and future understanding of our moving Earth.